Let's start learning the basics of building modeling. For each of the steps we are going to use this sample plan for reference and create a building model for this sample plan. First is the wall. Wall constitute shell and internal partitions of a building model. In Revit, walls are 3D parametric elements that host elements such as doors and windows and also define rooms. Walls in Revit are elements that represent the physical walls of the building. Like in real life, they can be monolithic or composed of parallel layers of materials. Since we are drawing by referring to a sample plan, let's start from a corner which has the measurements available. I am going to start at the bottom right corner. As you can see, I have already opened the sample project in which we set the levels. Walls can be placed in floor plan view or 3D views. Let's go to the plinth floor view. We can see that in the ribbon, wall is denoted by a split button. When we click on it, a drop-down with different options shows up. Select Architectural Wall. Immediately a contextual tab and options bar opens with windows needed to execute the steps in placing the wall. The Properties tab also changes to denote wall properties. First step is to select the wall type. In the Properties bar, clicking on the drop-down gives a list of the walls available. This list varies depending on the template file chosen when we start Revit. Depending on our requirement, we can select a wall from this list. We can also modify existing wall types to create a new wall as per our preference. Since we are working in meters and as per standards, I require a wall of thickness 0.23 meters. As such a wall is not in the list, I am going to create it. We are going to start by duplicating an existing wall and then modifying it. I have selected the 20 cm basic wall. Then clicking the Edit Type button opens the Type Properties tab. Here we can see the wall parameters. There is also the Type option which shows the list of wall types and also Family option which lists the different wall families. Since I want to create a new wall, let's click on the Duplicate button. A Rename window opens and I am renaming it to 23 cm brick wall. Now we can modify this wall. In the list of parameters, click on the Structure parameter. The Edit Assembly dialog opens. Here we see that the wall now has only one layer of 20 cm. I want a wall with a brick core and two sides finished with white paint. So I am inserting two more layers. Then I am modifying them to finish type. I am also rearranging the layers. The thickness of these layers is to be 1 cm. So all layer thicknesses are edited accordingly so that the total wall thickness is 23 cm. We can also preview the modifications using the Preview button. We can see that no materials are assigned. Let's click on the small button in the Materials row to edit the material. First I have selected the brick layer and from the Material browser I have chosen brick material. We can see that the Graphics tab shows how the wall appears in different views and their hatches. By clicking OK, the material is applied, which we can see in the preview. In the same way, I am selecting the Finish layer and opening the Material browser. Since white paint material is not already available, I am creating a new material using the Create button at the bottom and renaming this to white paint. From the Asset browser, I am choosing the Appearance drop-down and from it I am selecting the white paint finish. Now we can see that the material has the desired properties. Other modifications can also be made if needed. We can also add image for design and texture if needed. Now I am applying this to the finished layer. I have repeated the same steps to apply paint finish to the other layer also. Now we can see in the preview pane that the changes have been applied to the wall. By clicking OK, the type assembly dialog closes and we can see in the type properties window that the changes we made has created a 23 cm brick wall as per our requirement. Closing the type properties box by clicking OK saves the wall we created. Now that we have created a wall of 23 cm, let's see the steps in placing it. If we see the properties bar, there are some options available. The wall selector drop-down shows the type of wall selected. The location line shows the option of how the wall is placed. The base constraint is the level at which the bottom of the wall is to be placed. Revit automatically selects the floor plan view we are working on as the base constraint. Since we are working in plinth floor plan view, plinth is taken as the base constraint. We will see base offset and top offset later. The height of the wall can be defined in two ways: the unconnected height and the top constraint. For any default wall, the unconnected height is automatically set to 8 meters. This is used when we are not depending on preset level lines to set wall height. The top constraint option is used to set the height of the wall using already preset levels. All levels above the base constraint level are displayed in the top constraint drop-down. Since we want the wall to go up to the ground floor roof level, I am selecting that level as the top constraint. On the options bar, we can see a few more options. Since we have selected the ground floor roof level as top of the wall height automatically shows at 3.15 meters. The location line determines how the wall is placed. There are different options in the location line drop-down. By using the center line option, the wall places such that its center is the reference for placement. There are also other options. The finish face exterior option places the wall such that the reference for placement is the exterior side boundary. Let's select the center line option. The chain option creates continuous walls for each click, similar to the polyline tool in AutoCAD. Let's place the wall of the room in the bottom right corner. The first click specifies the start location. When we move the cursor, we can see some blue dimension lines show up. These are temporary dimensions which help in placing walls of specific measurement. We can either move the cursor and click at the desired measurement, or we can type the measurement. Since we have selected the location line to wall center line, we can see that the wall shows a dotted center line which we can use as a reference for placement. The cursor point is also on the center line of the wall. Since the wall length is 3 meters, I am typing 3 and pressing enter. We can see that the wall of 3 meter length has been created. Since the chain option is checked, a new wall has automatically started at the end point of the wall. I'm using this new wall to continue drawing the other 3 sides of the room. After finishing, we can see that when I select a wall again, its temporary dimensions show up, showing the interior dimensions between the selected wall and next parallel wall. We can see that the interior dimension shows as 2.77 meters. The reason is that we drew the wall using wall center line option. So when placing wall, Revit has measured the 3 meter as a center line to center line measurement. We can change the dimension by clicking on the temporary dimension and inputting the measurement as 3 meters. In this way, I'm correcting the interior dimensions such that the room is of 3 meter by 3 meter size. The wall center line option is more useful when we already have a center line grid over which walls are being placed. In the sample plan, we can see that the 3 rooms at front all have their length as 3 meters. Let's create a grid using these measurements and place walls using the grid as reference. From the ribbon, go to the Architecture tab and in the Datum panel click the Grid button. Since we have already drawn the corner room, we can use that wall to create the first grid line. When we bring the cursor on the wall, Revit automatically detects the center line as reference, and by clicking on desired position we can start the grid. Similar to the wall placement, we can either move the cursor to desired measurement or type the measurement. Clicking again in the end position creates the grid line. Here we can see the grid line has been created. The name of the grid is seen on only one side. Select the grid and then a small box is seen on the side of the grid with no name. Check the box so that the grid name appears on both sides. When one grid line is created, the next lines can be created by different methods. One method is to copy the first grid line and pasting it at the next wall position. The second grid line has been created in this way. The next method is to use the Create Similar option. By selecting the grid line and right-clicking on it, we can see the Create Similar option. Clicking on it activates the grid command. Now we can use the Offset option in the Contextual tab to specify the offset distance. It is 3.23, adding room size and half wall width on either side. Now if we trace on the position of the previous grid line, a new grid line is created at the specified offset distance. I am creating the next grid line by selecting the last grid line, and then using the copy tool I am selecting the distance between the previous two grid lines as the reference to place the new grid line. Thus, using different methods, the vertical grid lines are created. The horizontal grids can also be created in the same way. The first horizontal grid line is created using the Create Similar option, and next line in the same way. The next line is drawn using the Copy option. We can also approximately draw the grid lines and then select the grid lines and edit the measurements afterwards. Let's try by drawing the next line approximately. We can also edit the start and end point of the temporary dimension by clicking the point and dragging it to new position. Now I have selected this line, and by clicking on point of the temporary dimension I am adjusting it to new position, which is the grid line. I am editing the dimension to 3.73 meters, which is the position where we want the grid line. Now we can see the grid has moved to the new position. Now that the grid lines have been drawn, let's add walls using the grid lines as reference. Since we need the type of wall with the same height and properties of the previous walls we have drawn, I am using the Create Similar option to draw the new walls. When we see the Contextual tab of the Wall option, we can see few tools in the Draw panel. These tools are helpful in drawing different shapes of walls. By default, the Line option is selected. By using the other options like Rectangle, Inscribed and Circumscribed, Polygon and Circle, rooms in these shapes can be created. Pick Lines option can be used when we are tracing over an imported CAD-based plan. It is also used to trace walls over existing reference lines or other lines in the floor plan. Since we have already drawn the center line grid, we can use the Pick Line tool to pick the lines in the grid and create walls on the grid. For this option, make sure that the location line for wall placement is set to Wall Center Line in Options bar. Now when we select a grid line, we can see that a wall is created on the full length of the grid line. Whenever there is an overlap in walls, or If there is any error, the warning bar shows up and the element having the error is highlighted in orange color. We can make the necessary corrections using the modify tools. Here the length of the walls are more than what we need as the pick tool has traced over the entire grid line. We can use the fillet tool from the modify panel to edit the walls. Fillet tool works by joining the two walls we select. We should always select the walls such that we are clicking the cursor on the part of the wall we want to keep. Revit takes the side in which we click as the needed side and removes the other side. Here, by clicking the needed sides of the two walls, the fillet tool removes the extending part of both the walls. Since two walls have been placed, I am deleting one of it here. Instead of the pick line option, we can also draw a wall using the grid lines as reference. Since we are drawing over a centerline grid, we are using the wall centerline option for the location line. Now, by clicking the cursor at the start and end point of our desired location, walls can be placed. We can see that Revit automatically joins the walls whenever two walls intersect. Here the chain option is selected. But we don't want to draw continuous walls. In this case, instead of closing the command and then starting again from the first, we can click on Escape key once to break the continuity and start wall at new location. Keep in mind that clicking the Escape key twice closes the command completely. Using these techniques, I have drawn and modified most of the interior walls. I have intentionally left off drawing a few walls which we can draw one by exploring few other options. We can also use the trim or extend option to remove unwanted walls. Here, to edit the wall, I am using the trim tool. Always save the project frequently and also whenever the save reminder dialog opens. For using trim tool, select the place or line at which the wall should be cut as the first point. The side which is to be retained is selected next. Revit keeps the selected side and removes the other side. Since two unconnected walls are retained, an error window opens. There is an explanation of the error and also solutions. We can select the Unjoin Walls option as we need both the walls to be retained. Looking at the sample floor plan, we can see that few of the walls are 11.5 centimeters. Let's create this wall type. Since we already created a 23 centimeter brick wall, we can use that as a base for this new wall. Click on the wall button. Then in the properties bar, select 23 centimeter brick wall, then click the edit type option and the type properties window opens. Let us duplicate this wall and rename it to 11.5 centimeters brick wall. Now if we click the edit button in the structure parameter, the type assembly window opens. As we duplicated the 23 centimeters brick wall. Here we can see that the properties are same. We just need to change the thickness of the structure core to 9.5 centimeters. Now we can see in the preview pane that the thickness has changed. By clicking Apply button and then the OK button, the changes we made are saved. Here we can see that in the properties bar drop down the 11.5 centimeters wall is also present now. Let's see the steps in placing the wall. First, let us check the base constraint and top constraint to make sure that our desired options is selected. Looking at the sample plan, we can see that the top wall of the bedroom on the left side is a 11.5 cm wall. It needs to be placed 3.5 meters from the bottom wall. For this we can use the offset option in the options bar. First type the measurement in the offset window. Then we are changing the location line to finish face interior as we want the interior dimension between the two walls to be 3.5 meters. Now we are going to trace over the interior side of the bottom wall by clicking at the starting point of the wall. We can see that a new wall is created at 3.5 meters from the previous wall. By tapping space bar we can change the side in which the wall is placed. Clicking the end point places the new wall. Now using the measure tool we can check if the interior measurement is 3.5 meters. As it is correct, we can fillet the two corners to close the room. In Revit we have the option of correcting errors in dimensions and also properties of elements at any point of time, instead of deleting and redoing it again from the first. Looking at the sample plan we can see that few walls are of 11.5 centimeters thickness. But we see in our drawing that we place the grid and wall as a 23 centimeters wall. Now how do we change it? Not to worry. First we can change the wall type. For any element in Revit there are two sets of properties. They are the instance properties and the type properties. Instance properties of any selected element is shown in the properties bar. The modifications in the instance properties like base constraint, base offset, unconnected height, top constraint and top offset change only the properties of the selected element. The type properties is opened by clicking the Edit Type button in the properties bar. If any changes are made in the type properties, it affects all elements in the project of the same type. Since we want to change the wall type of only this wall, we can select the wall, and in the instance properties we can change the wall type in the drop down. We can do the same step to the other walls to be changed also. Now we can correct the interior dimensions of the room by moving the walls and grid lines. First let us use the measure tool to check the existing dimensions. When we measure, it is seen that the room size exceeds by 0.0575. Hence we have to move the wall and grid by 0.0575 meters. We can select the grid and wall to be moved. Select the Move tool and select the point of reference for moving the wall and grid. By moving the cursor up or down we can choose the direction in which the walls should move. Since we want to reduce the size, I am moving down the cursor and then typing the measurement. After clicking enter we can see that the wall and grid has moved. Now we can measure again and check that the dimensions are correct. We can see that the room length has changed to 3 meters. In this way, by using the temporary dimensions and move tool, we can correct any dimensional errors. The measure tool is advantageous when we need to only check the dimension instead of creating a dimension line. Measure tool creates temporary dimensions which disappear when escape key is pressed. By using this method, I am now correcting the other walls to make sure that the Revit project is having the same measurements as the sample plan. Let us draw the remaining walls. We can use the Offset tool even without going into the Wall command. Directly select Offset tool. The copy option is kept checked as we want to duplicate an existing wall. Then input offset distance. Then move the cursor onto the wall to be offset. By placing the cursor on each side of the wall, we can see that the wall placement side changes with movement of the cursor. Clicking on the desired side places the wall. Here we can see that the wall we offset was an outer wall. The whole length of wall has been offset. We can edit the length of the wall using the Trim or Extend Multiple Elements tool. First select the position at which the element is to be trimmed. Then select the side to be kept. We can see that one side has been trimmed. Clicking on an empty area restarts the command and we can trim the other side in the same way. We can also check the dimensions and make changes if needed. The wall we offset was drawn with location line set to center line. When we input offset dimension, it takes the center line to center line measurement as 1.8 meters. That is why the interior measurement is 1.57 meters. By selecting the wall and using temporary dimensions, we can change the dimension to 1.8 meters. To place a wall only for a specific length, we can use the Offset tool within the Wall command. First select the Wall tool using Create Similar option. Set the location line to Finish Face Interior as we want the interior dimension to be correct when we place the wall. Then go to the Offset window and type the distance to be offset. Here it is 2 meters. Then by tracing the existing wall, a new wall is created parallel to the existing wall at the distance we specified. Again we can measure and check to see if placement is correct. When we want to cut a wall, we can use the Split tool, which is found in the Modify panel. This tool makes a cut on the wall in any point specified by clicking the left mouse button. Let us cut this wall at 2 points. We can delete the cut portion and then edit the remaining wall ends by using Trim tool and Delete tool. Another way to create a wall at a specific position is using Reference Plane. Select the Reference Plane button from the Architecture tab of the ribbon. By using Offset option, we can input the length to be offset, which is 2 meters. Now start to trace by clicking on the first point on the reference wall. This starts the reference line at the offset distance. Clicking spacebar can change the side of placement, and clicking at the second point creates the reference plane and closes the command. Now using Wall tool, we can trace over the reference plane to create a wall in that position. When we use Wall Center Line option, we can see that the cursor places wall such that the center line of wall is on the reference line. However, our requirement is interior dimension. So we can change the location line to Finish Face Interior. After the wall is created, we can select and delete the reference plane. We can also use reference planes when there are no walls to use as reference points. Take the sit-out area for example. We need to create a wall at 1.84 meters from the bottom. First we can create a reference plane at the wall boundary. Then by using the Move tool, we can move this plane to the distance of 1.84 meters. Now using the Wall tool, we can draw a wall tracing the position of the reference line. After the wall is created, we can select and delete the reference plane. We can draw curved walls by using the tools in the Draw panel after selecting the Wall tool. The Start and Radius Arc tool creates curved walls based on the starting and ending points and also the radius specified. The Center and Arc creates wall based on the center point and radius. The Tangent and Arc creates an arc from the end point of the previous line. By using the Fillet Arc option, a curve can be made between two joining walls. As these walls are not needed in the current project, I am deleting them. By changing the detail level to fine, we can see the hatch pattern of the walls. By changing the visual style to shaded, we can see the colors of the wall. By changing the drawing scale, we can see the finer detail of the wall finished thickness. Thus, the view style of the walls can be changed according to preference and sheet requirement. We can view the created walls by going into the default 3D view from the quick access bar. In this way, by using multiple tools and methods, walls can be created and modified. Now that we have created all the walls by referring to the sample plan, let us add doors to the walls. Since the grid lines are not needed for adding doors, we can hide them. Select the grids. Click over the temporary hide or isolate button and then select the hide element option. Now we can see that the grids have become invisible. When there are hidden elements in the view window has an outline with text temporary hide or isolate shown such that we are reminded that we have hidden few elements. Now looking at the plan, we see that there is a discrepancy in how the wall line weight is displayed. This is because two walls are in the same place. We can delete one of the walls by selecting it. Let's click on the door button. We can see in the properties bar drop down that the type of doors available are seen. We can see that I have only flush door listed with different sizes. The number of doors already present also varies depending on the project template used. Now let us try selecting a door and placing it. For the main door, I am selecting the door of width 915 mm. When we move the cursor, we can see that the temporary dimensions appear. We can use these as guidelines to place the door. When the door is placed at a distance from the wall, we can locate position of the wall with temporary dimension. In the sample plan, we can assume the distance to be 10 or 15 centimeters. Here I am using 10 centimeters as the distance and placing the door. For the interior doors, I am selecting flush door of width 864 mm. Again, I am placing the doors in place with help of temporary dimensions. We can tap the spacebar key to flip the door swing direction of the door. For the bathroom doors, I am selecting flush door of width 762 mm. Again, I am placing the doors in place with help of temporary dimensions. Now checking again with the sample plan, I am modifying the door positions. By selecting each door and using the temporary dimensions, we can modify the door position to reflect the sample plan. Now let us modify the height of the doors. First select the door and then click the Edit Type button. The Type Properties dialog opens. In it we can see that the height, width and materials options are available. We can see that the preset measurement is 2.134 meters. Let's change it to 2.1 meters. We can see that materials are given for the door and frame. We are keeping the default materials for now. When we apply the changes, the height changes for all doors of same type in the project. In the same way, we can change the height for the interior and bathroom doors. Next, we can add openings. When we select the door tool, we can see the Load Family button in the Contextual tab. Clicking it opens the Windows Explorer with a collection of default families available. For Indian versions of Revit, this is available within a folder named India. Here we can see a list of folders with different types of families. We can open the Doors folder. Here a list of different type of doors are available. We can also see a preview of the selected door at the right. Since we are going to add openings, select the opening. Now we can place the openings using the temporary measurements as guidelines. We can also change the width of openings using the Edit Type button if needed. Now let us change the height of the openings by clicking the Edit Type button and changing the height. In this way, doors and openings can be added to the project. Let's move on to windows. In the sample plan, we can see that it has single pane windows, 2 pane windows and 4 pane windows. First select the window button and we can see the available options. We can see that only one type of fixed window available. Click on Load Family button. Open the Windows folder. We can load our needed type of windows from the available options. Since we need a single pane type and double pane type, we can load the single and double casement window available. Once the desired type of windows are loaded into the project, we can edit them according to our need. First, let us select one of the available sizes of the double pane window type. Now we can change the measurements to the required size. Click the Edit Type button and in the Type Properties dialog we can see the list of available parameters that can be changed. I am changing the height to 1.5 meters. I am changing the sill level to 0.6 meters and window width to 1.2 meters. Click OK to save the changes. Now we can add the double pane window to the required positions in the project. Similar to placement of doors, we can use the temporary dimensions to assist in placing the windows. When we move the cursor for using the temporary dimensions for placing windows, it automatically snaps to the center of the wall length to help with placement. This option is useful to place windows exactly equidistant to the two perpendicular walls. Let us place double pane windows wherever we need within the project by referring to the sample plan. During placement of windows, the orientation of placement can be changed by tapping the spacebar key. After placement, it can be modified by selecting the window and then clicking the double side arrow which shows up next to the window. We can see in the 3D view that the windows have been placed at the correct levels. Now we can edit and place the single pane windows in the same way. Click the window button. From the drop-down, select a single pane window to be edited. Click on the Edit Type button. Now we can change the window height to 1.2 meters, width 2.6 meters and sill level 2.6 meters. Once the changes are made, we can place the windows. Four windows need to be placed in the top left corner. To place windows equidistant from each other, we can use the dimension tool. First, I am approximately placing the 4 windows on the wall. Now, selecting the dimension tool from the quick access toolbar, I am measuring the distance between the wall and midpoint of each window as a continuous dimension. Moving the cursor and clicking on the desired point places the dimension line. Now we can see an EQ symbol crossed off. Clicking on that symbol modifies the position of the windows such that they are placed at equal intervals on the wall. Now that the windows are placed at equal intervals on the wall, we can delete the dimension lines. An error window pops up to ask if the windows should be constrained or locked to the position. Since we may have to change the position later, I am choosing the unconstrained option. Now we need to place a 4-pane window. But 4-pane window is not available in the default families. Hence, to save time, I am going to place 2-pane windows close together to represent 4-pane window. I am selecting the 2-pane window which we modified using the Create Similar option. Now I am going to place them overlapping each other and adjust the position. We can also use model lines to help us place doors or windows in exact location. Select the Model Line tool and then draw lines parallel to the existing walls. Using these lines, the midpoint of the wall in desired region is found. Now we can adjust the windows such that they are placed center to the dining room area. Once the placement is correct, we can delete the model lines. Now we can add the ventilators for the bathrooms. Ventilators are also a type of windows with a higher sill height. Let us select an already available window and duplicate it to create a ventilator. I am choosing the single casement window. Now open Type Properties by clicking on the Edit Type button. Next, click on the Duplicate button. Rename to Ventilator. Now we can modify the size. Let us change height to 0.6 meters and sill level to 1.5 meters. We can change the width to 1 meter. Click OK to save the changes. Now we can place the ventilator on the host wall. By moving the cursor and using the temporary dimensions, we can place the ventilators to both the bathroom walls. Even though the ventilators are placed, they are not visible in the plan view as the cut plane of this floor plan is set to sill level. However, the ventilators are detected when we move the cursor over them. We can see in the 3D view that they have been placed correctly. Now let us see the settings involved to make the ventilators appear in floor plan view. Let us go back to floor plan view. When Node Tool is selected, we can see that the Properties bar shows options corresponding to the floor plan view. Let us scroll down. We can see the View Range option. Click on the Edit button next to the View Range to open the View Range dialog. Here we can see few options. Since we are working on the plinth floor plan view, the bottom shows the starting point of that level. The top level shows the level up to which the elements are visible in this floor plan view. Cut plane shows the position at which the floor plan is cut. Here the cut plane is set to 1.2 meters so that it cuts through the doors and windows. We can change it to 1.6 meters so that it also cuts through the ventilators. Now when we click apply, we can see that the ventilators are visible. Thus, using different methods, windows can be placed and modified in Revit.